Gentlemen and others, it's a great privilege and honor to be here tonight. Thank you so much for the invite. I think we are exceptionally humbled by the turnout, and it obviously means one of two things. Either the topic is extremely relevant, or we're really good-looking guys, and I don't think it's the second. So it's really, like I say, an absolute privilege to be here. My name is Kenneth McPherson, and as mentioned, we've got Adam Carlos. He is one of our technical engineers that runs our service center at our head office in Joburg. We also have branches in Durban and in Cape Town. And then Alvin, he does sales for us every now and then. He's now the Saimc Joburg chairman, so he's forever attending meetings and making other plans and trying to get things happening.
And you still pay him.
and we still pay him. He's obviously really good at when he does spend time on our products. I was briefed beforehand, and so I'm going to say this up front so that we're all on the same page. And I know I will probably be, I can't swear here, I will probably be in a little bit of brown spilly stuff afterwards. But I was told beforehand that this is a technology evening. And of course I was really excited because we are innovators in technology. And we lead and direct the market in a lot of our technologies. It changes the way the automation market grows. And then I was told, but we're not allowed to punt our products. So, so tonight is going to be a little bit interesting, a little bit different. And I'm going to talk to you about the technology of industrial PCs. Of course, industrial PC and a commercial PC are... It's been a hot topic for many years, and when I'm saying many years, for at least 10 years. And I've been with the present company that I'm with for about, 6 years ago we opened the branch, and I was working with a product for about 4 years before that, so also for about 10 years. And I'll never forget, 10 years ago, it was really a market response along the lines of, what is an IPC? And why? Why IPCs? And over time, as IPCs have become more adopted, either through machines that are coming from overseas or through plants as they grow and require much heavier processing power, the idea of what is an IPC is still, believe it or not, a little bit unclear. And people still today are not sure what it is that is the difference between a commercial PC and an IPC. So what I'm going to do is spend a short amount of time, about 15 minutes. I'm going to go through a couple of things. I have a short, relevant video at the end to play. And this is more to just spark a different awareness about what is the technology out there and why industrial PC. So, once upon a time in the 1980s, there was a requirement for something a little more than just what in those days were microprocessors. They needed data collection and data acquisition. They needed to be able to massage the data into some sort of relevant reports, and this could not happen easily. It was practically impossible. They were running around with clipboards and trying to manually collect data and make some sense of it. And of course there were many questions to the reliability of that. And so in 1986, and this is not a product punt, this is straight out of a German research material, one of the large global customers that is also in South Africa requested of Beckhoff a control system that could have a hard drive on board. And so the idea of putting PCs into control systems was born. So what is this? What is this whole idea of an industrial PC that's living in the plant, that is not in a nice, pretty, air-conned environment, and that is exposed to all sorts of vibrations and heat and shock and all sorts of other treatments? What is it? What does it mean? And how is it different? Well, firstly, and I think this is probably the most obvious, and this is really where most people think it actually starts and ends, is the housing. It will look different, yes, and there's reasons why the housing looks different, and the housing needs to be ruggedized, it needs to be a bit strong and robust, it needs to be able to handle certain environments and be able to withstand certain shocks and be shielded from certain electromagnetic interferences and so on. But at the same time, it needs to house very sensitive, very high-speed moving components inside. And so there are a vast number of housings, and there's a lot of ideas behind housing. Should it be aluminium? Should it be plastic? Should it be stainless steel? What are the advantages? What are the disadvantages? Why would there be these sort of requirements for differing housings? And apart from then the housing, the control environment lives for a lot longer than your traditional commercial environment. And the longevity of parts availability is obviously a big concern. With an industrial PC, you need to know that once you're buying something and you're putting it in and it is controlling your machine, that's fine. And normally you don't have software updates and OS updates and have to worry about viruses and all these other things that commercial PCs are very busy with. And 6 months down the line after buying a desktop or a laptop, you need to make a change to RAM or make a change to something and the parts are obsolete. With IPCs, they're sitting in the plant, they're doing a specific purpose for which they were designed. They're running the software which was designed to run the machine in a certain way. And that doesn't normally change. That machine is normally then set to do a job for a while, and the only changes that happen is maybe more modules are added onto the machine or to the plant or to the process itself. But the actual software that's running doesn't normally change, and therefore you don't need that sort of updates and those sort of regular changes. But then you need spares, and you need to know that there's an availability for parts. And you need to know that the parts that are then in the IPC are going to last longer than 6 months. Because in some organizations it is acceptable that after a year to 2 years you just get another desktop. Because it's acceptable that this desktop is now old, it's now had its share of viruses and spam, and it's just not coping. So it's fine, it doesn't have to last more than 2 years. You can't have that when you're running a plant, you can't have that when you're running a machine, or even a building. It's just not acceptable. The next thing that needs to be borne in mind is compatibility. How easily is it when you buy the next machine, or you upgrade the line, or you expand the machine or the plant? How easy is it for the new controller, perhaps a new IPC, to talk with the current one, to share data, to give accurate reporting back, to be able to manage that whole process of that plant, even today with the big focus on energy, to be able to manage energy consumptions of different machines in different areas of the plant, and to be able to share that data and to present it in a way where you can actually do something about it. There's of course a big thing on different power measurements and data measurements and so on, but all of that's useless if you can't make any intelligent decisions. If the machine can't then decide to do something about that, okay, so we know we're using a lot of power. We didn't know that before, now we know how much it is. That's not good. But you can't make a decision, you can't do anything about it. And then in machine builder type environments, of course, it doesn't really matter where the machine goes. You need to be able to look after it, service it, back it up, support it, have the correct environments in which this happens. And most of the machines today have to operate in what we call a real-time environment. In other words, you dictate as the machine designer the exact amount of time that the program has to do all of its calculations, all of its logic, update all of its I/O, speak to all of the motors, do whatever it has to do, get that info back, and then run it again. And if that is not done in a specific time, then very often your product that is being built will be varied. And sometimes it's something that you think is irrelevant, like the wall thickness of a yogurt cup. But if you are injecting plastic and you're not reading back from your wall thickness sensor in real time, then that variance could equate to a huge amount of waste. And that waste can actually pay for another machine, another line, another upgrade within a very, very short amount of time. We have a beautiful case study from a very big American firm in North America, a company by the name of Husky. They pretty much own plastic injection molding globally. And they upgraded, and they found out that purely because of a much quicker response time in a slow process, their wastage paid for the upgrade in 8 months. They didn't upgrade for that reason. They upgraded because it was a lot easier and cheaper. But yet, that sort of real-time capability has a whole lot of positive outcomes that are often not seen up front. The heart of any PC, be it an IPC or a commercial PC, the heart of that is the motherboard. And so when considering a PC-based control system, a control system for a plant or a machine that has to have these very high levels of real-time capabilities, processing power, being able to talk to SCADAs and MESs and ERPs, being able to store data, being able to manipulate it and give you reporting, all of that clocking and processing and calculation is happening at the motherboard level. And when you consider an IPC and you consider that the motherboard itself needs to be made of extremely high qualities, it can't just be a commercially bought motherboard. It has to be a motherboard that is actually designed and manufactured in-house by the company that's building the IPC. What is the reason for that? It's quite simple. They know what their goal is with the IPC that they're building. So when they design an IPC, they know exactly how many different form factors, how many different housings, how many different styles. Is it going into an IP67 environment? Is it going into a stainless steel, pharmaceutical grade, food grade? Is it going to do this? Is it going to do that? And how many different insides, internals, can be used across those form factors? Because if you only have 4 or 5 different motherboards, but you have a range of 20, 25 different PCs, you're actually minimizing the risk to yourself, but you're making it easier for servicing and spares and parts by simply using the same insides. It's like the frame of the Hilux and the Fortuner. It's exactly the same underframe. Now they're using the same platforms between Audi, what's the new little Q3, and the A4 sedan. And it's all the same underneath, the same sort of suspension layout and monocoque design, but yet it's so many different frames for different purposes on the outside. It's exactly the same with the motherboard. When you start off with the internals, if you have a few number of very, very highly designed, very high quality motherboards that you can use in many different platforms, you are on a very good wicket as far as having something that's available for a long term is concerned. You've sorted out the flexibility, having something that's compatible to talk to many different field buses, to many different control systems that are out there. Being able to add on different cards. Some, I know for example with plants in this area, some people have a Moore or a Honeywell or a Yokogawa system where they need a specific PCI card slotted in, or maybe a mini PCI card slotted in. And the motherboard needs to be designed for that up front, not as an add-on afterwards like sometimes happens. And so something that is made in a country that has a very high focus on quality and design would go a very long way in your decision in comparing an IPC to something else. Then there's also a distinction drawn when you start thinking about the people who are going to work with this. How much interaction are they going to have with the controller? What are they going to be doing with the machine? Where's the machine going to be placed? What sort of shock and vibration and that sort of thing is concerned? Then when you think about future and what we call future proofing, how things change. I mean, here you have a design of an IPC housing, and that was designed about 7 years ago. And back then, the latest Intel motherboard, the latest chipset that was used on the motherboard was an Intel Pentium 4. And that was on a traditional, what we would call an ATX-sized motherboard. Today, 7 years later, you have the same exact housing. Nothing's changed. So if your machine was designed for that, and you're still building those machines and selling them into the market, the housing, the layout, the setup of your control cabinet, the wiring, everything stays the same. Nothing's changed. But inside now you're running one of the latest i5 or i7 Intel chips on still an ATX-sized motherboard. And you have the advantages of what some people would say old-fashioned. You have the advantages of the ATX motherboard with things like those full-length PCI cards that you can still slot in. On a new chipset, on a new IPC, but it'll still run that perfectly. The whole layout in your cabinet hasn't changed. When you think about the environment in which the PCs operate, there's a wide range of factors that have to be considered. A lot of these PCs get handled very roughly. We actually have an internal company joke, and that's a good thing that our company sells industrial PCs, because sometimes when we take our PCs to exhibitions and we pack up after that exhibition and you're really tired and you pack up really a lot faster than you set up. And sometimes those PCs tend to accidentally fall and knock and end up all over the show, and at the next exhibition they work perfectly again. And I think if we sold commercial PCs, we wouldn't do very well with our demo stock. But that sort of environment happens in a factory. It happens in a floor. We've had PCs in a quality environment where a fork truck knocked the thing over while it was running. It was acquiring data, hit the ground, broke. Did the screen break on it? I can't remember. It didn't even break. The pole broke.
The floor broke also.
Wow. And the PC was lying on the floor, still running perfectly. Happily clocking away, acquiring data, writing to the hard drive, doing its thing.
Good hard drive.
Quite all.
And there was no issue, nothing. Not a crack on the motherboard, not a scratch on the PC. Purely because of its design. Because these sort of things are taken into account at the design level. If that's not considered in a purchasing decision up front, then you won't have that sort of non-production loss, the lack of waste.
Sorry, another example is when a certain amount of PCs were purchased, one had fallen off at the airport somewhere along the line. It looked really terrible. That went in for testing, came back, no fault whatsoever.
Yeah, we still took a photo of that box.
That as well, yes.
Absolutely, absolutely. Can't trust shipping companies. We have since changed our shipping company, by the way. A perfect example of an environment where the PCs run 24 hours a day, 7 days a week, in quite a bit of vibration in that sort of an environment. And if the IPC in that case was not chosen correctly, they wouldn't get past about 2-3 weeks with a commercial PC, maybe 3 months with a poorly designed fake IPC, if I may say. It has to be borne in mind the environments into which these PCs go. And there's a lot of testing, in-house testing that happens with certain manufacturers. And this needs to happen because you cannot certify that PC to be able to withstand continuous shock at continuous high temperatures in a high humidity environment loaded with dust and all sorts of other toxins and pollutants in the air if you haven't proven that yourself. And so there needs to be a cycle of accelerated testing. There needs to be a specific burning tests that happen with each and every single PC that comes off the production line. And again, that plays a big role in how the PCs are put together. Here, for example, is a climatic chamber. It's a chamber in which you can put a PC into. You can fire it up, you can run it at 100% CPU usage. You can take it to, let's say, 55 degrees ambient temperature, and within a couple of minutes drop it to 0 degrees. Then you can inject it with 90 to 95% of humidity, whack it back to 55 degrees Celsius, drop it back to 0, and do a whole range of crazy things with the thing in a climatic chamber. This sort of exposure, this really hammers a PC. And this shows design flaws, this shows weak spots. And if this is done correctly in the design phase, then by the time the IPCs come out in production series, you have a PC that is going to last in the most incredible situations. We're talking on these massive wind generators in mountains in China in the middle of snow and then in the middle of boiling hot summer, and the PCs will run and run and run. Dirt, humidity, we've spoken about that. Rubber industry, for example, that's a feeds and milling plant, and the PC runs right there. I don't know if you can even see it in the horrible, dusty, dirty, that fine milling of the maize and the wheat, and it runs in that sort of environment. Another big factor, of course, is electromagnetic interference and static discharge. A PC has to be able to run through that if it's a properly designed industrial PC, because you will have static buildup in any factory. It doesn't matter what lengths you go to ensure protection for that. Moreover, when you buy an IPC, the service area and the service center of the company from which you buy, do they have the proper sort of electrostatic discharge protection? Do they have anti-static flooring? Do they have certification for that? Are they tooling? Listen to me. is the tooling set up in the correct environment so that when your PC is being worked on, you know for a fact that no damage can happen to it, no harm can happen to it, that nothing can go wrong with it as a result of a very poor environment. We've spoken a bit about rough handling, another example in the automotive industry. So really, that kind of draws to a close just that raising of awareness of the difference between an RPC and a commercial PC. PCs are built for a wide range of applications, and so you get them in a wide range of housings and in a wide range of sizes and functionalities, different abilities for expansion, for different card slots, for different sort of uses. And this has changed a lot over the years. And again, we are quite fortunate to be able to say that right from 1986, when the era of IPCs began, since then Beckhoff has pioneered many different designs, many different innovations in the automation environment. And this needs to be considered when choosing an industrial PC. Are you buying from a company who actually understands automation, who going forward into the future is still innovating, is still taking technology to a new level, is still using and utilizing various technologies in a wide range of fields, even if you don't use a whole lot of products from a company like that, it still needs to be considered. And the reason that PC control has become so popular, PC-based control has become so popular, is because you get such a high degree of performance. You get 40 to 60 times the performance out of a CPU, a normal little Intel PC-based processor, than you would get out of the top-of-the-range traditional PLC. You have a whole lot of integrated functionality. So now on your PLC, which is running on an IPC, you can have your HMI environment or your SCADA environment. You can have your databasing and a server style of functionality. You can also have all the functionality going back to your ERP and MES systems and all the data that gets moved around for production process, for quality, for example, recipe changes, recipe handling, automated machine setups, tooling, talking to other functionalities, be it robotics, be it something on the floor level, be it safety environments. And that is given to you in a sort of environment on PC-based control where it is really, really easy and very inexpensive. You have something that is proven because it's not only one company that would use, let's say, an Intel chipset, for example. This is widely used, widely proven. You have stability from a company that creates IPCs from an environment and a background like what you've seen, where you know that going into the future that PC will be supported and that there won't be a high cost in servicing if servicing is required. Because it's not necessary, because there's been a standardization of components where possible across the range. So even though the range is so wide, you are able to standardize many components. I'm going to close really just bringing across a philosophy ideal. And this is something that, of course, we pride ourselves in as a company, but it's something that goes with the technology and it goes with a consideration of any product. It really doesn't matter what the product is if a company tries to tie you in to their hardware, immediately it flags warning bells. Why would they not want to eliminate hardware dependencies? Because they're not confident in their products. If their products and their technologies are open to standards, open to all technologies, and open to any sort of being able to talk to field buses, being able to talk and communicate to most of the world runs on be it Microsoft or Linux, be able to talk to these things easily, then it would raise and ring warning bells. When your solutions are focused on software, and the software is running on this sort of a proven, reliable platform, you know that you're not caught up with these sort of black box dependencies, where you have a black box and that is specifically for high-speed measurement of analogs or pressures, and you have another black box and that's for specifically another purpose, and you've got no access to them, and you're kind of stuck with the hardware in that sort of scenario. When companies are able to develop plants and expand them on a PC-based platform, then everything is accessible. Yes, there's an inherent danger with that, but that comes with knowledge and with sharing knowledge and increasing the right use of the technology. You start getting guarantees through using standard open products. Guarantees in performance, guarantees in longevity. You get guarantees in the fact that you don't have to worry in the future about, are you tied into that supplier or can you use anything else? And the ranges of PCs available on the market, there is new hardwares coming out all the time. You get thinner, more service style industrial PCs, you get the new multi-touch idea. We've seen this for many years already on these tablets and on these smartphones. We have multi-touch. There is a company, we have done a little bit of research, there is the first company that we have found that is introducing this in an industrial PC to the market, and almost before software is available to use their technology. So most SCADA packages, most HMI packages today on the plant floor cannot yet use the multi-touch, zoom in, turn the thing, zoom out again, have a look at your overview of your plant. Oh, there's a motor flashing red, zoom in on that motor, it's now this big, turn it, have a look, 3D it. The hardware is capable. We've done a bit of research and I've got a video about this company that is able to do this already. Then also customer specific panels. There are companies out there that will build PCs, screens, and combination of screens for other manufacturers, for other companies, to their spec, because of their history, their pioneering of the technology, and because of the reputation that they have in the market. Again, when you're choosing IPCs, it has to live in a real world, and in a real world a PC is doing something for the production. Be it a plant, be it a machine, whatever it's doing, it has to be able to interact. And if you look at that same company and you look at how it interacts with other components of automation, I/O, motion, how is it established across the world? Do they have a large footprint? What sort of evolution have they got in their ranges? How have they changed? Then you'll get a very good feel of whether you're looking at buying an IPC from a reputable, from a correct sort of technology, from a correct background. When you think about changes in the market and the ability to eliminate hardwares, to eliminate black boxes, and do a whole lot more automation functions, and you hear new buzzwords in the market like scientific automation, then it'll give you that sense of comfort, that sense of awareness that you're dealing with a company who knows about environments, who understands what it means to put PCs into all sorts of really rugged, really hard, really demanding applications. I'm going to show you a short video, and then we can do a couple of questions. And this is a video of this company that we have found that can do this multi-touch screens.
At the 2011 Nuremberg exhibition, Beckhoff introduced two completely new ranges of products, panels and panel PCs, the common feature being multi-touch technology. What we know from the consumer branch is that you can simultaneously make multiple inputs. This is already usual in phones or tablets, and we make this suitable for industrial use, bringing it to the machine. To do this, we've created a series with new displays and new properties. Einmal klassisch 4:3.
The classic 4:3 format, which is the basis for the customers of today having an automatic HMI, human-machine interface. And then there is the new format, 16:9, to show other machine concepts in widescreen. We use a robust aluminium housing. All edges are protected, on the reverse side of the IP65, therefore depending directly on the machine. Or the other type for installing in the control cabinet, in the wall housing or other places. But multi-touch is everywhere.
Multi-touch ist überall dabei. Die Einbaugeräte.
The built-in units have a sleek aluminium frame. Even the sides are protected. This is continuous, consistent glass, i.e. no damage can be done from the front, it can't be broken. And all the devices are made flat. If I take them out, you would see there is only 2.5 centimeters of case thickness. This is the same here. Also, these devices are built incredibly thin, which means this side of the housing is incredibly thin and elegantly equipped. All displays have an LED backlight. This makes it possible to install it horizontally in landscape mode, or even vertically, portrait mode, as one can make wholly new machine concepts. So, even without multi-touch, one can easily use this new format and say, I'm not yet interested in multi-touch, I just want the new devices. One can simply show the different systems. And then come completely new formats. We have that here. For example, 18.5-inch widescreen. So far, nothing like this has been available through Beckhoff. It is something we're experiencing new for the first time in all devices, as a panel PC fully integrated. And since we've managed to make the device incredibly economically, it's now of interest to everyone, not just for the multi-touch user, but for all other customers, since the devices are cheaper than the previous technology.
Gentlemen, I thank you, ladies, thank you. It has been a real honor to spend some time here. I look forward to chatting a bit more. If there are questions now that are relevant to the group, please fire away. Otherwise, chat to us one-on-one. If they're really heavy technical questions, Adam is here. if they sales-related, Alvin's here. Otherwise, fire away.
I see with the 18.5-inch widescreen, is there a bigger unit?
There is. It's available up to 24-inch in that 16:9 aspect ratio, that widescreen ratio.
Your price comparison on a
very good question, and I think seeing as the technology show is over, I can speak freely. Beckhoff has a philosophy that when new products are released, as you heard Roland say there, it is always in the interest to try and find production processes and ways of building the parts more efficiently. That means that we can launch them to market cheaper than, for example, a product that it replaces. In this scenario, with these widescreen formats and with these new multi-touch screens, we are not replacing a product. Our existing product range, the 4:3 ratio ranges that is used very widely, will still be available and supported and developed. But these new screens are available at a cheaper price. And so that is always been the philosophy. And that is also why a lot of the very, very old parts, yes, they're available, but still at their price, which is now comparatively more expensive.
Okay, the operating system that runs on this PC is normal. I saw Windows embedded and XP. Is that more or less that runs on these PCs still? Because that is usually a problem with, because Microsoft is evolving so fast, and usually the software you need to run the machines are tendence to not to grow as fast.
Correct.
So
100% correct.
More than 90% of the PCs that we sell today still have Windows XP Pro installed on it. Although you can't buy XP in a commercial environment, you can't go to Incredible Corruption and buy a PC with XP. 90% of your applications are written and the drivers for those applications are available.
So it's a full Windows XP version. You can run any third application software that runs machines or anything.
Correct. As a manufacturer, we are one of the very few Microsoft partners, and we have chosen this as a design path strategy back in the late 80s, early 90s. And it was a good choice because 90% of what's out in production environments today runs on Windows. Having said that, and having looked at the development in solid state and in PLCs, Beckhoff is one of 5 Microsoft Embedded Gold partners in Europe. So what this means is that, yes, a lot of our technologies, a lot of our products from the motherboard up are designed with Microsoft in mind as an OS. But it doesn't mean that it can't run Linux or any of the other operating systems. And we have many countries, for example, a lot of the mines in Australia, they buy just the hardware without OSs, and they run their own systems on there.
Yeah, because what I saw these days is, for example, PCs that you buy, like that commercial PC, doesn't support XP anymore. You can't even load it on it, it doesn't work.
Absolutely.
So the problems we got with industrial PCs, well, we call it industrial, we still use commercial PCs for industrial PCs, more or less, is the problem that you have to keep the old technology in, because some of the vendors still support only Windows XP, for example.
Absolutely.
And then you set with a problem now, what hardware do you buy? Because it creates a problem of operating system, because Microsoft is evolving so fast that nobody can keep up. And they've got 3 stories buildings of programmers only designing new software, so
Correct.
nobody can keep up. So
Correct.
I'm just wondering how long still will.
And that is an important point. And just for interest's sake, at any given time, there are 3 Microsoft engineers on Beckhoff's premises in Germany at the factory. And this is part of being a partner with Microsoft, is that all the early editions are tested and are thoroughly tested. Even though, as Alvin correctly mentioned, factually, most of the PCs we sell are still with Windows XP today.
Because that is still the most stable operating system since Win
Correct.
NT.
And this is a very interesting thing about the industrial environment, because yes, we as a company are driving innovation and driving technology forward, and we're the first company in the world to launch a lot of things, and the latest being the multi-touch. And yet at the same time, the industry itself often requires what is far behind in commercial terms. And to be able to support that is very important. Is very, very important.
That becomes a real problem.
So even though for the last 3 years on our price list, you can buy one of our IPCs with Windows XP Pro and Windows 7 and any of the other options, most of the people still will choose the XP Pro option.
Yeah, because if Windows XP is supported on PCs for the next 10 years, I agree it will be fine, because I know that most of the PLC vendors and control vendors still prefer to leave it there, because it is still the most
proven,
stable operating
they
system.
know it inside out.
Yeah.
Absolutely correct.
Because with commercial PCs you're lost.
Yeah. And also, when you design a machine or a plant, you're designing it in an era, and you're using software that's available to you. And if your software that you're running on an industrial PC is designed with XP and so on in mind, then that's what you're using, and that's what you have to use. Once it's designed and commissioned and that plant runs, and it runs into the future, it really doesn't matter that that software is growing and changing and evolving and developing, because your system is running as it was designed to run. Here, though, in the future, can that be supported? That is a big question that needs to be asked up front when you purchase an IPC.
I don't want to keep everything after that.
There are still PCs running with DOS-based operating systems.
Yeah, last year we had
were
that.
able to support and provide, I think it was...
I know some
Was it the
other
woodworking
systems still
industry?
prefer
Yeah.
the DOS-based system. So
In our industry, I think it's more, if it's not broke, don't fix it.
Correct.
It's not like we're dealing with a printer driver. We're dealing with machines that are
Yeah, I
turning out
agree.
our product and our money at the end of the month.
Yeah.
We're not worried about, does the printer work? Am I going to be able to use this keyboard? It's our machine that we need to keep running. And that's why industrial PCs are still with XP, because it's tried, because it's tested. And, it's still,
and most
still
of the
working.
vendors' programs still runs in that environment.
For them to update their whole SCADA program and say,
it's-
now we are working on Windows 7, costs a lot more than what it costs HP to say, here is our new Windows 7
Yeah.
driver. It's not, it's more of a, we have to sit down and really re-engineer everything. And that's why XP, and now, I mean, our PCs with Windows 8 coming out in 2013, we're ready for multi-touch. That's, I mean, we're there already. And it's not even released yet.
Correct.
So as long as you can keep up with those basic principles.
And that's just on the
So we
software
just keep
side.
supporting the old
You
stuff,
have to
because
Yeah.
some guys will just never go there. Maybe in the next 10 years they will.
Yeah.
But for now, in the current environment, I know this is a big issue.
Correct.
The
It's a huge
software.
issue, because it's
Yeah.
unacceptable in our environment for you to phone me and for me to say, like a commercial PC would, yeah, but we're in this era now and we're only supporting Core i3 and we're only supporting Windows 7. That's obsolete. That we haven't got.
Yeah, we
It's
can't work-
unacceptable.
we can't
You
work
cannot
with
do
that.
that. So the fact that right now, one of the other programs of which Beckhoff is a member is Intel's Early Adopter Program. Again, one of the very few exclusive members in the world. So right now, we'll be testing the new Core Octos, and we'll be testing the new Windows 8 and the multi-touches. And yet at the same time, the engineer at the next desk is supporting an old DOS-based system that was running a PLC perfectly for the last 25 years and had an issue. And so that
As long
range
as that is
of
there, it's
scope
fine.
and that window is huge, it's massive.
But the advantage of being on that Intel partnership is that the industrial PC that you choose, you know that the processor is not going to be a processor that's going to be on the market for 6 months and then fall away. And then after a year or 2 years or 5 or 8 years, you at least know what your industrial. And that's one of the things with industrial PCs. One of the main differences between a commercial PC is that you know that in 8 years' time, when you have a problem with the machine that you bought now, because you're expecting that life cycle out of your machines, it's able to be supported.
Of course, I know the design for Microsoft on an i7 processor, Windows XP hasn't got the capability to use the full processor because of the bus speeds and.
Yes.
Okay, I don't want to get too technical about this, but it's but still, if it works with it, then it can be used, and that's the whole thing. Okay, I'm just.
What's your take on PCs with no moving parts, no moving fans?
Well, of course, we have them available in our range, the solid-state range, where there are not even fans on the PCs. And I scrolled very, very fast through the product side of it for obvious reasons. But from our point of view, there are various designs with massive heat sinks on the side and cooling fins and complete solid-state environments where the PC would run. The ambient temperature we would certify it at might be a bit lower. So most of our PCs will run at 55 degrees Celsius ambient temperature. I mean, that's the motherboard running at like 80, 90 degrees Celsius. Happily, 100% CPU usage running, flat out, all the time, certified. In a solid state PC, we might drop that from 55 degrees ambient to 45 degrees ambient. But it'll run, and it's certified, and it'll do the cooling with passive cooling, no problem. So where the environment
is there any
calls...
major difference?
There are some people that are just really, really averse to moving parts. And they say, we will design our press, and our press will have no moving parts on it, finished, done. And that's fine. And they'll buy the solid state. There are other people that will treat the PC as part of the process plant. So in your process plant, you're measuring your level sensors, and you're measuring what's happening on your flow rates. And when your flow rates start dropping, you know there's either a blockage or there's a problem, you can flag an alarm. And the motherboard, we have an SMB bus running on it, which is part of an IC standard that you can read into most SCADAs, and you can flag an alarm to say, hang on, the 5 volts is still there, but the fan speed's dropping, must be dirty. And so in the same way, flag alarms, because it's part of your same process, and therefore go and change. And so we would then design, and we have that, removable fan cartridges, where you don't touch the PC. The PC's on and running and clocking away. You walk up to it and you unscrew the fan cartridge and you clip it out, and you clip in a new one, and you screw it in.
That's the first thing that goes.
And the process, exactly, and the process doesn't know anything about it. The PC doesn't know. You go back to your SCADA, you reset your alarm, you see your fan speed, you see your voltage, you see your motherboard temperature, along with all your other alarms, your level sensors and everything else. It's all part of the same process. And when that mindset understands that this is my control system and starts utilizing all these things that are available to them from an industrial PC, then yes, you can avoid a lot of problems with moving parts. You don't have to be, oh, we will not have a moving part. It's, you know, you can avoid those hassles.
How about corrosive atmosphere?
Yes, correct. There is a, how can I say this politically correctly?
Sure.
Look, it's facts, so I'm going to say it. There is no way you can conformally code to motherboard. Because there is too much else that is vulnerable and weak. And it doesn't help you conformally code to motherboard, and the power supply still dies because the air inside it is dirty. And so this is why we would have such a wide range of PCs, because we'll say to you, where is the PC going? Oh, it's standing on the factory floor. Fine. Then you're only going to look at our range of fully sealed up, completely enclosed PCs, where you can't have access to anything. It's a complete IP65, there we go. Or, okay, it's going in a cabinet. The cabinet's got filters and the cabinet's got air quality measurements, and you want, let's say, a nice thin 19-inch rack industrial PC, then you know you're buying a PC for a cabinet. It's a cabinet mount PC. It's not a PC for out in the environment. Same with chemical exposures. There are different ratings and different exposures on our screens and on our PCs for different chemicals. And yes, pharmaceutical industry, there's certain chemicals, but they're different to, for example, this environment, Sasol, and these sort of chemical plants. And then you get, of course, the food and beverage market. And yes, you can spill milk on a screen and leave it there for 3 days and wash it off, and it doesn't affect the screen. But other chemicals can't be on the screen for more than 12 hours, for example, before it has to be sprayed off as part of the shift change or whenever they do that, depending on the environment it's in. And so we spend a lot of time at a design level where the guys say, we need a PC, be it to run a simple quality control program on the floor level and eliminate clipboards and production managers walking around trying to track things, albeit for controlling the PC and running the PLC on the PC and running the SCADA and talking to MES and ERP systems, we will then get involved at that design level. We'll get to know the plant and the environment. We will make a few suggestions. We will get a feel. The customer up front will already know and say, I want to use this new portrait idea. And then we will look from the ranges and see what is suitable and advise accordingly. So yes, you are 100% correct. The PC has to be used in the environment for which it was designed. And that eliminates that whole thing of, well, what's your take on corrosive environments? You have to know where you're using it already up front.
There are a few case studies within the factory, and for any further information you can contact Nick or myself, and we'll address your issues regarding corrosive installations.
We've got PCs inside a platinum refinery, in the actual refinery, where it's a very harsh environment. I spend a lot of money buying big blue expensive instruments and then they put plastic bags over it. And we've got, there are PCs in that environment that have proven themselves and are lasting. But exactly what Kenneth said is we look at each application and we'll say to you, okay, we don't have, there's a lot of people out there selling PCs and they've got 4 different choices. You can choose this one. We'll sit down with you and say, okay, the best solution for this application is X, Y, and Z, and try and advise based on that.
Again, thank you very much. I appreciate the turnout. I appreciate